All right, yo ho ho, my friends. We had such a good session yesterday. We're going to keep at it today with part 2 of lesson 4.3. As always, this is Mr. McCarthy dropping knowledge bombs all over the place. So buckle up for the learning. Same goals as yesterday: identifying classifying prisms and pyramids, and identifying the solid figure that can be formed from a net. We did the first part yesterday. Now we're doing the net part today. All right. Okay. A net is a plane figure that can be folded to make a solid figure. More than one net may form from the same solid figure. So just imagine that you were cutting like the wrapping, like very perfectly cutting the wrapping off a gift and then flattening it out with no overlaps and no gaps. That's what it should look like. So basically you're disconnecting all the sides and folding it flat. So that's what a flat cube looks like. Okay? You got to use a little bit of the power of your imagination. No, we go the other way. So now there are more than 2 nets that can make a cube, okay? This guy here would fold down, this guy here would fold up, these 3 would fold and wrap around over here. Oh, this one's a little freaky-deaky. Imagine folding that one down, and then when you fold that one down, this one folds down over here, then you fold this one back. This one goes around the back side, and then this one covers the bottom. Trust me, it works. If you don't believe me, draw it, cut it out, and do it yourself. Ideally, you'd have these on paper. You could probably hold your paper up on your screen and do these, but you should be able to look at them and kind of figure out what they would get. What do you think you're going to get from this? Oh my gosh, that looks just like a rectangular prism, you say? Okay. And what are you going to get from this? Oh, you're going to fold that to the middle, that to the middle, that to the middle, and you're going to get this beautiful triangular pyramid. Oh my goodness. You guys are brilliant. Good job. Next side. Okay. Copy the figure, then draw to complete the net of the cube. Oh, look, there's 1, 2, 3, 4, 5. What do we need to do to this bad boy to make it a cube? Go. Then I'm going to think for a minute and figure it out myself. All right, 2 ways you can do this one. You could either go like that, or you could go like that. Okay, imagine this is your front. No, this is your front. That would be your top. That comes down to form this side. This comes down to form that side. This would make the bottom. You need something to form the back. Okay, so if you had one here, that could flip up and form the back. Otherwise, this goes down, that wraps around the back. Again, you might have to cut some of these out and do it. It's hard to explain something 3-dimensional on a 2-dimensional screen. Right? Right. What solid is formed from this net? I'll wait. Did you say triangular pyramid? Of course you did. Nicely done. Oh, this is kind of a sneaky little monkey here. It says this is the net of a cube, okay? And then each one of these vertexes is named right here, okay? Fill in the rest of these. So fill in each one of these is a point. Fill in each one of these. I'm going to actually pause and try and figure this out myself. Go. Man, I actually had to use my brain on this one. But what I started with is aligning this FG and C, and realizing that this is the this square right here is the base, and that I'm looking down into the box. Okay, so that when I fold this side of the box up, boop, the H is right there, the C is back there. Then the D folds up over the C, and then I fold this side of the box up, and the E is above the F, and the A is above the B. Kind of a brain spinner, but there it is. Oh my goodness. Almost broke into a sweat over that one. All right. Go. Pause me and then go. All right. Is this what you got? Are the faces all squares? Yes. Are there two bases? I mean, when we're looking at a prism, we're only acknowledging two bases at a time. So yes, everything else is just a face. Are the bases parallel and congruent? Yes and yes. How many faces connect the two bases? 4. Can a cube be called a rectangular prism? Yep. Can a cube be called a square prism? Why not? Of course it is. The squares are bases, so it's a square prism. Can a rectangular prism be called a cube? Occasionally, or yes, if all of the faces are squares, but not always, okay? This is not a cube. It's a little bit longer one way than the other, so it's just a plain old boring rectangular prism. Oh boy, get out of here. All right, look at these prisms. Copy and complete. Pause, and after, we shall meet. That's good. Don't be jelly. Pause it. Go. Well, friends, I'm going to just go out there and say this one wasn't exactly rocket surgery. How do the sides of the base compare to the number of rectangular faces? They're equal. Big secret, eh? Do this again. This one I'm just going to do with you. Look at these pyramids. Copy and complete the table. Triangular pyramid has 3 sides on the base and 3 triangular faces. Square pyramid has 4 sides on the base, 4 faces. 5, 6, 6. Samesies. That's an official math term, is samesies. When you get to 6th grade next year, make sure you tell like Mr. Freeze or whoever else teaches at Southview or Valley View that samesies is an official math term according to Mr. McCarthy. True story. All right, let's carry on. Let's practice. You should have these identified already. What is this thing? It is, yes, a parallelogram. I know some of you are sitting there screaming, rhombus, rhombus, rhombus. We don't know if it's a rhombus unless we know that all the sides are equal, and it's hard to tell. So parallelogram is the safe one. This clearly is what? Oh, you guys, well, by the way, you can pause me. Go ahead. I'll wait. All right, let's move on with the show. Hexagonal prism, triangular prism, and freakadeaky, octagonal pyramid. It's got 8 sides. You can see a little stop sign hanging out down there. Octagonal pyramid. Okay, bring all the points up to the top. What do you get? Square pyramid. Oh, very good, class. Yes, that's a square pyramid. Fantastic. Wait, what? 4 items found in a supermarket that are of each shape? Shape. Prism. Let's see. Kleenex. Cheerios. Don't criticize my spelling. What else? Pasta. But these are all rectangular prisms. Oh, wait, but I'm going to throw you a curveball. Toblerone or Toblerone or whatever that candy is called. It's a triangular prism, not a prism. Broccoli. Melon. Bag of chips. What else? Item number 4, something really weird at a grocery store. Handful of applesauce. I'm not sure if that's a unit by which you can buy it at the grocery store. I don't think it is. Anyway, you guys get the picture. Please be the end, because we're almost to 10 minutes, and I think you wonderful, wonderful citizens have got this. Wait, no! Oh, that's a little funky. Wasn't supposed to pair deck on me like that. Here we go. Oh, there I am. Well, I feel like I should be able to continue and go next. Right? Don't you agree? Oh, there we go. What? There's more? Difference between a prism and a pyramid? One base, two bases. Apex, no apex. Because the first one's a sphere and the second one's a cylinder. Okay, finally, 7 and 8. What kind of prism has 8 faces? Well, there's a top and a bottom, so -2. That gives you a hexagonal. Because you'll have 6 sides or 6 faces, a top and a bottom for... Okay, this isn't clear. This would be... If you count the bases, then it's hexagonal. But if you're... No. Okay, let's back up. It says a blank prism has 8 faces. Okay? If you were counting the 2 bases as faces, 1, 2, and then 3, 4, 5, 6, 7, 8, you've got a hexagonal prism. If you're not counting the 2 bases, you're just counting the faces around the side, then you have a octagonal. And the same one down here, a pyramid. If you're counting the base, it's a pentagonal pyramid. If you're not counting the base, then it's a hexagonal. These are poorly worded. That should tell us if they are or are not including the base in that count. I'm not afraid to call out when I think something is not as good as it could be. Oh, okay. These are fun. This is basically true, false. Can they be turned into cubes or not? Yes or no? I might have made this. I'm gonna let you figure that out. That's your problem of the lesson. And then finally, your teacher's gonna assign some homework. Do whatever they tell you to do, and then here you go. That's what it looks like. Oh, I went overtime on this one. Shame on me. That's it. I'm going to cut you off right now. This is about all of me that you can take for one day. Be well. Work hard. Good luck. You know, if you have any questions, either contact your teacher or scream to the sky. Whatever works for you. Bye, friends. See ya.